Good day, guys. This is your tutor engineer. Today we are continuing with graphs and motion on one dimension. Let's start with today's lesson. When is the distance traveled by an object equal to the magnitude of the displacement? So the comparison is between the distance and the displacement. They are only going to be the same when the object, let's say object travels in a straight line. And does not change direction. Okay, that is the answer to question 1. Then question 2. The diagram shows the position of a cyclist at various moments in time. At each indicated time, the cyclist turns around and moves in the opposite direction. That is, the cyclist moves from point A to B, from point B to C, from point C to D, from point D to E as shown by the dashed lines. Okay, so the question is, use the diagram to determine the distance traveled and the resulting displacement of the cyclist at the end of each 1 minute interval with respect to time is equal to 0. So we'll choose time is equal to 0 at the starting point here at A, and also the displacement and the distance will be 0 here at A, so point A is going to be our starting point. So let's start with when on the first minute. So the first minute, the cyclist will be traveling from point A, which is at 0 meters, all the way to point, okay, so this is point B, right? This is going to be point B. What is the distance between point A and B? Is 150 plus 300 plus 150, which is going to be at 600 meters. So that will be the distance at 600 meters. It will also be the displacement, 600 meters. So let's just, for the displacement, just bear in mind that the direction matters. So we'll choose going to the right hand side as positive, and then going to the left hand side we'll say it's negative. So now the next iteration of the cyclist is between point B, which is at 600, to point C, right? So the distance between point B and C is 150 and 300, but since the direction is to the left, we'll make it negative. So minus 150 minus 300, that will be minus 450. So when you put 450 and 600 together, for a displacement, you'll have minus 450 and 600. It will give us 150 meters. But for a distance, you don't regard the signs. The distance is always positive. So for a distance, you'll just say 600 plus 450. So the 450 becomes positive. The sign is always positive for a distance. That's the difference when you're calculating a distance compared to a displacement. Okay, so let's just also complete this column. The displacement is positive here, and the displacement is positive here. Okay, so let's continue for the next stop of the cyclist. So from point C, the cyclist is going to move to point D, which is 300 meters to the right. So 300 will be positive since it's going to the right. So we'll have 300 meters. So to calculate a displacement, you'll say 300 minus 450. In fact, you're not going to say minus 450. You're going to say plus 150, right? So you'll choose the last value of the displacement, which is the previous one was 150. So you'll say 300 plus 150, which will give us 450 meters, which is positive. Okay, so the distance, you're always going to add cumulatively. For a distance, you're going to take this value and then you add 300 onto it, which will give us 1350 meters. And then the final stop for the cyclist would be at point E. So from point D to E, since it's going to the left, it's going to be negative minus 300 minus 150 minus 150. So you'll have minus 600 here. So you'll take that minus 600 and then you'll add it to the previous amount, which was 450 meters. It will give us minus 150 meters, which is negative. And then for the distance, you'll take the previous value 1350 and then you'll add 600, since for a distance the numbers will always be positive. So you'll have 1950 meter for a distance. So that's it for today's lesson. I hope you liked today's lesson. If you did like it, please hit a like button and subscribe, and stay tuned on the next lesson. Cheers.